I guess we can talk a little bit about the technical things that we go into and the kids learn about when they build a robot and go through season. In the pre-season in the fall, we do have learning sessions that our professional mentors teach the kids about. And one of the big ones is the electrical systems, which is, if you get in close, this is the guts of the robot down there, and that's really the biggest part of the robot is the controller. What we use is the C-RIO. It's a controller used from National Instruments. Another big system they learn about is pneumatics. So we have the compressor and the tubes and the cylinders and the gauges that they have to learn how to use, or they have to learn how to release the valve. They have to learn about safety. Pneumatics is a dangerous thing. There are limits in competition how much stored energy you can have. So the kids have to learn about what their limits are as far as stored energy, so how much they can have. The mechanical parts that they use, the motors, the wheels they use, their drivetrain. This is a the drive system this year is a tank drive. There are different drives available. They can use omnidirectional and they can use mecanum drives, which are really cool. They can go in circles and sideways and diagonal. And we've used that in the past, but this year we used the 8-wheel tank drive. And what was kind of exciting is that the kids designed their frame. We had a custom designed frame manufactured for us, but the kids designed it in CAD. They used SolidWorks three-dimensional computer-aided design program to design it, where all these keyhole slots are for their bumper system and so forth, as well as the whole robot. So this whole robot is in a CAD file somewhere, so that the students developed. This year's challenge was to shoot frisbees and climb a pyramid-type jungle gym structure built out of steel poles. The team decided to focus on shooting frisbees, so they had to build this feeder chamber mechanism that fed it into the shooter. Okay, these are operated by the pneumatics, these hooks, that allow it to hook onto the first layer of the climbing apparatus, and then the pneumatics would pull this down and lift the robot off the ground. Again, something the kids designed and built. So those are some of the skills. We learn metalworking. They have to learn how to use a drill press, table saws, band saws, lathes, all kinds of hand tools to go ahead and put all this stuff together. And then programming, another big part of the robot is programming. Our programming mentor decided to use Java, so our team programs in Java. It's an up-and-coming language. There's a lot of demand for it for number one, which is why he wanted to teach the kids Java. And then also, I guess it has some abilities that other software we are allowed to use aren't. I think the three programming language they can use are C++, LabVIEW, and Java.